Hello everyone, welcome to video machine learning lab session. In this session, we shall discuss the seventh lab program, that is to develop a program to demonstrate the working of linear regression and polynomial regression. Here we need to use Boston housing dataset for linear regression and Auto MPG dataset for polynomial regression. So let us first know what is regression. It is a statistical method used in machine learning and data analysis to understand the relationship between variables and to make predictions. The core idea here is to estimate how a dependent variable changes when one or more independent variables change. Then, what is linear regression? This models the relationship between two variables by fitting a linear equation to observed data. It is useful when the relationship between the variables is roughly a straight line. And when it comes to polynomial regression, it extends linear regression by fitting a polynomial equation to the data. It is used when the data shows a curved relationship between the dependent and independent variables. So this is the program. Here, this statement import numpy as np. This is to import the numpy library used for numerical operations. The second statement imports the pandas library used for data manipulation. And this is to import matplotlib's pyplot module used for plotting. So this statement, that is import seaborn as SNS, it is used for statistical data visualization. And this statement, it imports the train test split function, which is used to split data into training and testing sets. So the next statement, it imports the polynomial features class used for polynomial feature transformation. And the next statement, it is used for importing the linear regression class, that is used for linear regression. So the next statement is used to import the mean squared error and auto score, and these are used for evaluating the performance of models. And this final import statement, it is used to import fetch openml, and this is used to fetch data sets from the openml repository. So next we fetch the housing data. So this statement, it fetches the Boston housing dataset from OpenML and loads it as a pandas data frame. Here, this statement, it stores the data frame in a variable called Boston dir. Next, we need to prepare the data. So, we have this statement for removing the target column medv, that is house prices, from the data frame to create feature matrix, that is x Boston. So this statement, it assigns the target column medv to y Boston. So this statement is to ensure all columns in x Boston are of numeric type. That is, we are here we are performing the data cleaning. Next we have this statement which removes any rows with nan values from x Boston. So next task is to split the data. So here we split the data into training and testing sets. with 20% of the data as the test set. Next, we perform training the regression model. So, this statement, linear model is equal to linear regression. It creates an instance of the linear regression class. And the very next statement, it trains the linear regression model on the training data. Next is to predict and evaluate the Boston housing data, where this statement is to make predictions on the test data using the train model. Next, here we have three print statements, where the first one prints the heading for the evaluation metrics, and the second one prints the mean squared error of the predictions, and the third statement prints the R2 score of the predictions. Next, this section is to uh, plot the linear regression results for housing Boston housing data set. So this statement is it creates a new figure with specified size, and the next statement, this statement plots the predicted prices against the actual prices. And this statement is to plot a line representing an ideal fit where predicted prices equal actual prices. So next statement, if these two statements are to label x-axis and the y-axis, and this statement is used to give the title for the plot, and this statement adds the legend to the plot, and this is to display the plot. So next section is to next we shall learn the working of polynomial regression algorithm. So here this statement, it is used to specify the URL of the AutoMPG data set, and next statement, this statement, it defines the column names for the data set. Next statement, it is to read the data set into a data frame and to handle the missing values and comments. So next is to remove any rows with nan values from AutoMPG. Next, we need to, once we fetch the AutoMPG data, then we need to prepare the data. So in order to do that, we use these two statements, where the first statement, it selects the horsepower column as the feature matrix, and the second statement, it assigns the target column MPG to YMPG. So once we prepare the data, then we need to split into test and training data set. So for that, we use this statement, where it splits the data into training and testing sets, with 20% of the data as the test set. So these three statements are used to apply polynomial features, where the first statement, it creates an instance of the polynomial features class with degree 2, and the second statement transforms the training features into polynomial features, and the third statement transforms the test features into polynomial features. Next, we need to train the polynomial regression model using these two statements. So here first statement creates an instance of the linear regression class, and the second one trains the polynomial regression model on the polynomial transform training data. So next task is to predict and evaluate the model. So here this statement, it makes predictions on the polynomial transformed test data using the trained model. So these three print statements prints the mean squared error and auto score of the polynomial regression model's predictions. And as we did for the linear regression, we are printing the plot. We are plotting the plot here using these statements. So these set of statements are used to create the plot of the actual versus predicted MPG values, and also to add labels for x-axis, then y-axis, and to add a title and a legend and display the plot. This is the plot when linear regression was applied to the Boston housing dataset. It illustrates the relationship between the actual housing prices and the prices predicted by the linear regression model. So here the x-axis represents the actual prices of the houses in the Boston dataset, and the y-axis represents the prices predicted by the linear regression model. Each blue dot represents an individual house with its actual price on the x-axis and the predicted price on the y-axis. So the red dashed line represents the ideal scenario where the predicted prices perfectly match the actual prices. If all the blue dots were on this line, the model's predictions would be perfect. The closer the blue dots to the red dashed line, then the more accurate will be the model's predictions. So in this plot, many blue dots are close to the red line, indicating that model is making accurate predictions for many houses. The spread of the blue dots around the ideal fit line, that is the dashed line, it shows the variance in the predictions. If the dots are spread widely, it indicates that the model has larger prediction errors for those particular data points. The vertical distance between a blue dot and the red dash line represents the error in the prediction for that house. Smaller distances indicate smaller errors. This is the plot obtained when polynomial regression is applied to auto MPG dataset. This illustrates the relationship between the horsepower of a car and its miles per gallon, that is MPG, using a polynomial regression model of degree 2. Here x-axis represents the horsepower of cars, the y-axis represents miles per gallon achieved by the cars. So each blue dot represents an actual observed data point showing the relationship between horsepower and the actual MPG of cars. Each red dot represents predicted MPG value based on the polynomial regression model. The red dots generally follow the trend of the blue dots, indicating the polynomial regression model is capturing the relationship between horsepower and MPG to some extent. There are noticeable deviations when the predicted MPG values, that is, those red dots, do not align perfectly with the actual MPG values, that is, blue dots. This suggests that the model may not be entirely accurate in all cases. The spread of red dots around the blue dots shows the variance in the predictions. The pattern of the red dots indicates that the polynomial regression model is fitting a curved relationship between horsepower and MPG rather than a straight line. This is expected as polynomial regression of degree 2 fits a quadratic curve to the data. Thank you.